Welcome to the IDSS-Targeted Threat Messaging in High Impact Operations course. This is Unit 4, which focuses on how to downscale threat information prior to and during impacts from severe convection. This module will use a few cases to illustrate opportunities to provide targeted threat messaging for potential hazards from severe convection during the watch and warning periods. The first case we'll review covers Oklahoma and Arkansas on April 11, 2022. On this day, SPC forecasts a slight to enhanced risk of severe storms as shown here. Our focus is on a frontal boundary that we can see on visible satellite imagery across southeastern Oklahoma into northern Texas, separating cumulus clouds from areas with no cumulus. There are elevated non-severe storms over western Arkansas. By 2030Z, shown on the right, we start to see two bands of building cumulus. A northern one along a frontal boundary that extends into far northwest Arkansas, and a second one a little south along an apparent prefrontal trough near the Fort Smith, Arkansas area. As this course focuses on messaging rather than mesoscale analysis, I'll only be giving a brief overview of storm environment to help us focus on the where for messaging. At 20Z, the SPC mesoanalysis page shows an unstable environment across southeastern Oklahoma in the warm sector, with surface winds revealing a cold front progressing slowly southward. An elevated capping inversion is eroding across southeastern Oklahoma, while some SIN continues along the boundary over northern Texas, as well as along the frontal boundary over northwest Arkansas. This is confirmed by special 20Z soundings that show a capping inversion still in place over the Dallas-Fort Worth area, while almost gone in Little Rock. We have 50 to 60 knots of deep layer shear across Oklahoma and western Arkansas, so plenty of both instability and shear for severe storms across southeastern and east central Oklahoma into far western Arkansas, along and ahead of the prefrontal trough. 0 to 3 kilometer storm relative helicity suggests a favorable environment for severe storms and possible tornadoes across southeastern Oklahoma and western Arkansas, at least compared to northern Texas, which is also confirmed by the special 20Z soundings. This is also suggested on the significant tornado parameter plot on the right. The 18Z surface map shows the advancing cold front and prefrontal trough moving into southeastern Oklahoma with decent moisture convergence. This is also somewhat weaker across northern Texas. There is an apparent triple point west of Fort Smith, Arkansas, where the prefrontal trough intersects an apparent warm front that's over western Arkansas. And this may be where moisture convergence may be maximized, as hinted by the 20Z moisture convergence plot on the right. Here's the SPC mesoscale discussion for the area issued at 1930Z, leading to a tornado watch issued at 2030Z shown on the right. The watch covers a pretty large area over a 7-hour period. How might we downscale the threat messaging for the next 1 to 2 hour period? Is the threat equal across the entire watch area? Going back to the satellite image, our focus is on two bands of building cumulus that are highlighted here. The northern band is along the actual front, while the southern one appears to be on a prefrontal trough. Now, the northern band appears to be in a cooler, less unstable environment with 50s surface dew points. So my focus would be on the prefrontal trough cumulus band for severe storm initiation during the next hour or two, as shown by the yellow polygon, where the trough appears to intersect the warm front. Compared to the large watch area, my polygon focuses on the far northwestern part. There may be a severe threat later in the period across other areas of the watch, but for the next hour or two, I'm focused on the yellow polygon area, which includes the Fort Smith area, only a small part of the watch. How might I communicate this on social media? Here's how I would communicate the message, using a simple PowerPoint template and filling in the information I need. I can display my threat area or overlay it on a radar image. I then fill in the primary threats, timing, possibly a confidence level if desired, recommended actions, and a blurb on what I'm expecting over the next 1 to 2 hour period. This is just a suggested approach to graphically messaging the targeted threat. It's not the only way it can be done. Here are some NWS chat message examples for downscaled messaging in this example. I'm showing a general area message for the area that was previously highlighted, as well as a message focused specifically on a particular city or a portion of a county, in this case, Fort Smith, Arkansas. My focus is on what, where, and when. During the next hour, as shown on these visible satellite images, convection initiates on both boundaries, but the more intense storms are west of Fort Smith, Arkansas. Do you see how we could message this potential? Note that there is a considerable amount of data I did not show you, such as cam output, model soundings, or other types of satellite imagery that might also have helped. Now, if you take a look at the 2130Z image on the right, you'll note two things. First, the focused band of cumulus in southeastern Oklahoma, and second, the lack of deeper cumulus further south in northern Texas, except for one orphaned anvil, where convection is struggling to form in a drier and weakly capped environment. Now, storms could eventually form in northern Texas, but over the next hour or two, my bets are on southeastern Oklahoma, southwest of the storm that is approaching Fort Smith, Arkansas. The 21Z mixed layer cape image on the left shows an uncapped environment where the boundary is located over southeast Oklahoma, and recapping where we see converging winds over northern Texas. The SRH plot on the right shows a sharp environment change over far southern Oklahoma, with what seems like greater potential for storm rotation further north across southeast Oklahoma than close to the Texas border. However, the bullseye of higher SRH is likely the result of a more northerly surface flow behind the prefrontal trough. And for much of the southern part of southeast Oklahoma, the low-level shear is fairly weak, making large hail a greater threat than tornadoes. Where is surface moisture convergence focused at 21Z as shown on the left? There is some along the entire boundary from northwest Arkansas southwestward, but it appears to be maximized over interior southeast Oklahoma, where we may have a weak mesolow. This would be my area of focus for new storm initiation during the next hour or two. Here we have a new severe thunderstorm watch for far northern Texas into far southern Oklahoma. However, where within this watch can we message likely severe storm initiation during the next hour or two? My focus is along the prefrontal trough as shown by the yellow polygon. Once again, just a small part of the watch area. Here's how I would communicate the message using my PowerPoint template. I highlight the where, the what, which is focused on hail and wind, and timing for the yellow shaded area. Here's how I might message partners on NWS chat, which could also indicate an image if I use Slack. Focuses on the what, where, and when. During the next 90 minutes, satellite imagery shows severe storm initiation in that same area of interior southeast Oklahoma along the prefrontal trough. Further south, across northern Texas, no initiation yet, but a few storms could develop soon. Again, we successfully downscaled the watch message to focus on where severe storm initiation was most likely during the upcoming 1 to 2 hour period, despite the limited amount of data I presented. Now let's focus on the warning period. At 21Z, we have a developing supercell with weak elevated rotation located well southwest of Fort Smith, Arkansas. It is moving to the northeast, so you might expect the need to notify people in that city of the approaching threat. However, if a deep mesocyclone spins up, one should expect a right deviation in the motion vector, likely to a somewhat more eastward direction, which could take the storm south of Fort Smith. In this example, the severe thunderstorm warning polygon is much larger than the threat area. Where is the actual area of threat? In this zoomed-in view, I would focus on the area highlighted by the yellow polygon. That polygon excludes many of the towns indicated in the warning text product, which are not in immediate danger. Notice the towns in the official red polygon that are not in the path of the hazard, especially well south of the storm, which is highlighted by the orange shaded oval. The red lines on the text product indicate the towns removed in my smaller yellow polygon due to no imminent threat. How might we communicate this to partners through NWS chat? Here's how I would communicate the message. Now with Slack, we could include a graphic to illustrate what my text indicates. I'm focusing on the what, where, and when here, not the how or why. Targeted threat messaging doesn't just have to be focused on the imminent threat area. It can also be used for longer lead time decisions. How might we message hazard potential covering the next 30 to 45 minute period? At this time, the storm has deviated more to an east-northeast direction, which will take the bulk of the storm just south of Fort Smith, Arkansas. There is still a bit of uncertainty, so perhaps I would focus on the orange polygon area as my area of focus during this period. Here is how I would communicate the message. I have downscaled my focus area of greatest threat where people may need to take protective shelter. Does this provide better information to those communities than just a larger scale warning area? Here I'm providing a heads up downstream of the warning area. Later in time, the storm becomes tornadic with a split that occurs, with a left-moving hailer heading northeast and the tornadic right mover heading more eastward. We see a messy display of overlapping warning polygons. How might we utilize targeted threat messaging to focus on where the imminent threats will be during the next 10 to 20 minute period? As shown by the yellow polygons, in this case I might focus on two messages, one for the marginally severe hail threat from the left mover heading towards Rudy, and the multi-hazard threat with the right mover well southeast of Fort Smith, Arkansas, over the town of Barling, which is heading towards Central City and Lavaca. Given a favorable tornado environment and right deviation of the storm, I would be particularly concerned about tornado potential as well, including the threat of a strong tornado. So what would a social media graphic look like for this example? Here's how I would communicate the message via social media. Now, one could do separate graphics for each storm, but in this illustration I include both in a single graphic. It really depends on how much time I have to design these graphics, which, using a design template, should only take a minute or two to complete. Again, this is just an example of how this could be done. One alternative might be to exclude the confusing warning polygons and just focus on the yellow imminent threat polygons to reduce the potential for confusion. I could also have the what's expected as separate text in the Twitter message. So there are multiple ways this targeted messaging can be achieved. Look at the difference between the large overlapping polygons and the areas of imminent threat shown by the yellow polygons, which is less confusing. Later in time, our storm becomes a well-defined tornadic supercell as it continues moving almost due eastward. The white arrow indicates the expected motion of the mesocyclone over the next 15-minute period. We have rather large polygons, given the likely threat area for an eastward moving mesocyclone. And yet I can tell from the imagery where the hazard is located and where it's headed, right? So my targeted messaging focuses on the mesocyclone path, as indicated by the yellow polygon. My chat message to partners again focuses on the what, where, and when. This appears to be an ideal setup for a strong tornado given an isolated supercell in a very favorable environment. Can you see hints of accelerated inflow on the velocity image that suggests much greater SRH just ahead of the storm updraft? How could we provide a targeted message for areas 30 to 45 minutes in advance of the supercell? Given that each arrow represents a 15-minute mesocyclone motion, the yellow polygon shown here would be my threat area, with my chat message focused on the what, where, and when. Again, we can target our messaging beyond just the area of immediate threat to support longer lead time decisions. Well, here's what occurred in this event. We had very large hail and a few tornadoes just south of the Fort Smith, Arkansas area, as well as a few supercells producing very large hail across interior southeast Oklahoma. Hopefully you saw how we could use the data that we have available to target our threat messaging, not just during the warning period, but during the watch period ahead of severe storm initiation as well. We can target not just areas of imminent threat, but also areas further downstream to support longer lead time decisions. Let's look at another case across Oklahoma on May 15th, 2022. SPC had a slight to enhanced risk across much of eastern Oklahoma, our focus area. Visible satellite imagery shows a pretty well-defined southward moving frontal boundary across central Oklahoma, along with a surface trough extending southward from this boundary just east of Oklahoma City. We have an intense but weakening storm moving into far western Arkansas. Our focus is going to be on the eastern half of Oklahoma. Here's an 18Z special sounding for Oklahoma City, showing a very unstable but capped environment with decent deep layer shear for supercell storms. We have large D-cape and steep lapse rates supporting damaging winds, and large cape aloft supporting very large hail. Here are some SPC mesoanalysis page graphics for 19Z, showing an erosion of the capping inversion in parts of east central Oklahoma on the left image, when comparing ML cape at 17Z to that at 19Z, where we also have at least 40 knots of deep layer shear, as shown on the right image. The surface map shows the well-defined boundaries that we saw on satellite imagery, with the surface moisture convergence image highlighting a max close to where we have an intersection of the boundaries. This would be a prime area for severe storm initiation, with the cap erased. Here are some hazard-related SPC mesoanalysis page graphics. 0 to 3 kilometer SRH on the top left shows large values across northeast Oklahoma, but these are behind the surface cold front. In the warm sector ahead of the front, values are much less, suggesting marginal tornado potential. The top right image shows large cape in the hail growth zone, supporting a large hail threat. The bottom images are a significant tornado perimeter on the lower left and low-level cape on the lower right, suggesting just marginal tornado potential along the frontal boundary, maybe hinting at some potential for a brief landspout formation with convective initiation along the boundary. The 18Z HERM run simulated composite reflectivity images show very little convective potential until after 22Z in eastern Oklahoma. Not terribly impressive. Maybe severe storm initiation is not imminent. Despite this, the SPC mesoplots seem to suggest a more imminent threat. We have a severe thunderstorm watch in effect for east central and southeast Oklahoma. However, given what we've seen and what we observe on visible satellite imagery, that's shown on the right, where might we focus targeted messaging on severe storm initiation during the next 1 to 2 hours? I would focus on the yellow shaded polygon over the northern part of the watch and along the boundaries of interest, and perhaps highlight the greatest potential near the intersection of the front and surface trough over the northwest corner of the watch area. The watch indicates potential over a 6-hour period, but I'm targeting where the threat for storm initiation exists during the next hour or two. Now, not only could I message where severe storm initiation is expected during the next hour or two, I could also message where no severe storms are expected for several hours. In this case, the southern part of the watch area, right? Let's focus on severe storm initiation. How would I message my expectations on social media? Using my PowerPoint template for illustration, here's how I would message my targeted threat. I'm focused on the what, where, and when, with the option of adding a confidence indicator. I add a blurb about my expectations during the next 1 to 2 hours, which alternatively I could provide in the text part of my Twitter message. Here's how I might message partners at this point using Slack. I might message East Central Oklahoma partners on the imminent threat of severe storm initiation, while for Southeast Oklahoma, I might focus on a later threat during the evening, despite a watch currently in effect. 90 minutes later, visible satellite imagery shows the explosion of severe storms along the boundary, starting near the boundary intersection and developing eastward. Further south, there is hardly any cumulus, as there are no mechanisms there to initiate severe convection. Do you see how this messaging provides more useful decision support information than just a large 6-hour watch area? We have the tools and science to do better than just message that a watch is in effect. At 22Z, we see multiple potentially severe storms along the boundary in east central Oklahoma. Let's turn to the warning part of this case, with our focus on the western storms over Okfuskee County, which are highlighted here. Radar shows a large hail-producing supercell over southern Okfuskee County. Over time, the storm deviates to the right, and the storm starts to exit the initial polygon, shown as number 1, requiring a new warning issuance, number 2. The new warning text product on the left indicates a number of towns, including Hannah, which is likely not in the path of the storm, and Castle, which is behind the hazard. How can I use targeted threat messaging to really focus on the locations in immediate danger where protective action is needed now? Here's my chat message for partners, focused on the what, being tennis ball size hail and 70-mile-per-hour winds, and the where and when, being the towns in the path of the storm during the next 20-minute period. In 4 sentences, I quickly highlight what the lengthy warning text product does not: a better indication of the what, where, and when, and who's in imminent danger during the next 20 minutes, as shown in the white shaded area. If a staff member is dealing with social media, that person could provide a graphic like this through a pre-designed template. One has to be very efficient in designing these, as the hazard is on the move, and severe storm information ages quickly. Compare this to the severe weather statement issuance, which has some issues. It focuses on eastern Okfuskee County, while the polygon is over southern or southeastern Okfuskee. It indicates the storm is 4 miles south of Okemah, while radar shows it over Clearview to the southeast of Okemah, and continue to have Hannah and Castle mentioned, even though they're not in danger at this time. These are issues associated with the automation process of WarnGen. The human can use targeted threat messaging to be more specific accurate, and timely, with focus on the area of imminent threat. You'll also note a more southward motion indicated here, leading to a new warning downstream in Hughes County. The prior slide showed a social media graphic focused on the area of imminent threat, but one could also design a graphic focused on the 30 to 60 minute lead time area before the new warning is issued, supporting longer lead time decisions. 6 minutes later, at 5:34 p.m., the storm has potential for baseball-size hail and 70-mile-per-hour winds. It's a monster supercell. Here's the SVS for the new warning area. How might we message partners about the area of imminent threat for very large hail during the next 20-minute period, and where significant property damage is likely? Is it the entire downstream warning polygon? Note that the white arrow represents an estimated 20-minute storm motion. Here's my NWS chat message focused on the what, where, and when for this dangerous storm. I could update this message as frequently as every radar scan and could include a graphic through Slack. Where might we message a threat during the 30 to 45 minute period in advance to support longer lead time decisions? Well, my NWS chat message would focus on Wetumpka at 30 minutes ahead and Horntown and Lamar at 45 minutes ahead. I could also include this graphic through Slack and provide it on social media. So here's what happened. We had multiple severe storms producing very large hail within our storm initiation polygon, as shown here in green, as well as very large hail up to softball size with a storm in Okfuskee County that we focused the warning part on. Through these case examples, could you see how we can add considerable value to the watch and warning products through targeted threat messaging? So in summary, this module focused on targeted messaging during the watch and warning periods for severe convective cases. 2 cases were presented that illustrated how to utilize storm environment and storm structure data to target messaging on where severe storm initiation would likely occur within a larger watch area, or even target small-scale threats where a watch might not be in effect yet. The cases also showed how to target messaging during and just beyond warning periods. Keep in mind that lead time relates to the range of decisions you're supporting. Thus, greater lead time, even through targeted threat messaging, supports decisions beyond just taking immediate protective action. These cases were used to illustrate how targeted threat messaging can provide more accurate and timely threat information to support actionable decisions. It focused on social media graphics as well as NWS chat messaging. Now, an example template was utilized for our social media graphics as a suggested approach to illustrate what could be done in an efficient manner. Such a template can be altered as needed to provide the best information possible. The cases indicated that one needs both good science and solid, efficient communication to design effective targeted threat messaging. Thank you for completing this severe convection-focused case examples module. In the next module, we'll look at flash flood case examples.